Another key defense here, and this doesn't necessarily stop SQL injection outright, but it does significantly limit the damage that can be done, is network isolation. So let me show you what I mean by that. Let's imagine we have our attacker. The attacker talks to the web app talks to the database. So we've seen this concept many times before. Now, one of the things that we saw earlier on in this course is that the attacker can use an injection vulnerability in this model to actually create their own login. Either that or actually crack the password hashes using that pwd compare function. Either way, the bottom line is it's possible for the attacker to get direct access to the database. Now clearly, once that happens, SQL injection doesn't even matter anymore. They've got direct access to the underlying data anyway, but only if they can access that database directly. So let's do this. Let's roll this back, and instead of the web app talking directly to the database, we're going to drop a firewall in here. So the database sits behind a firewall, and the web app has to communicate through that before it can get access to any underlying data. Now that firewall keeps the database off the publicly facing network segment. The attacker has to go through the firewall. And of course, the firewall is configured in such a way that it will allow the web app in and keep the hacker out. So in this sort of model, this request would be rejected. Simply not going to happen. The question then comes down to what sort of rules are implemented on the firewall to ensure that this actually works. Because at some point, people do actually need to connect directly to the database. They're the people deploying the app or supporting the app. So how does that work? Well, one option is that the database may simply be in a private network segment, the same network segment that those supporting the application are in. Another option is that the firewall whitelists allowable incoming IP addresses. In fact, this is what Microsoft SQL Azure Database Service does. When you get yourself a new database, you have to declare the allowable inbound IPs. So it's not quite in an isolated network segment, but it does certainly put a limitation on who can connect. Now, one other concept that does come up a little bit that I want to touch on is the idea of actually having a service tier in here, so that the web app is never actually talking direct to the database. Now, what I mean by service tier is something like a web service-based abstraction, where the web application itself is talking to the service, and then the service is the one constructing the SQL queries. Advocates of this model will argue that it's a good design because the web app never has the opportunity to execute a SQL injection attack. It would have to be the service tier, and that's downstream of the web app, and the web app only talks to the service tier via agreed APIs. Now this is true. It certainly does offer a benefit to SQL injection, but it does also add some significant complexity into the app, and I wouldn't recommend going down this path unless the inclusion of the service tier actually offered some other tangible benefits to the app. So maybe it's a great way of abstracting the data tier away and having multiple client interfaces into it. A web app, a mobile app, integration with other internal systems. That might make sense, but purely as a defense, this does get to be a very clunky implementation, and it actually adds parts to the system that can go wrong. So in fact, there are downsides to adding this sort of level of complexity. There has to be an upside beyond just a defense against SQL injection, for which we've already seen many other mitigations. So do be very pragmatic if you're considering this sort of approach. Regardless though, keeping that database off the public net and away from direct access by attackers is a very good practice.